So our second panelist is Dr. Anthony Fauci, who is the director of the National Institute of Allergy and Infectious Diseases at the U.S. National Institutes of Health, where he oversees an extensive research portfolio focused on infectious and immune-mediated diseases. As a longtime chief of the NIAID Laboratory of Immunoregulation, Dr. Fauci has made many seminal contributions in basic and clinical research and is one of the world's most cited biomedical scientists. He was one of the principal architects of the President's Emergency Plan for AIDS Relief, a program that has saved millions of lives throughout the developing world. I'm very excited to hear him talk to us today about the latest advances in medical countermeasures and specifically whether or not we are any closer to a universal flu vaccine. Dr. Fauci.
Thank you very much. It's a real pleasure to be here with you this afternoon to talk about, as you see on this first slide, the pathways to a universal influenza vaccine. So I guess it needs to warm up, Josh. There you go. So I'm going to take two vantage points. One, to talk a little bit about the compelling need for a universal flu vaccine, and then talk a little bit about the pathway. What about a compelling need? Why do we really need a universal influenza vaccine? Well, there are three things about the status of where we are right now that are not satisfactory. The first is that the current seasonal influenza vaccines are not consistently effective for a number of reasons, some of which are beyond our control. If one looks at the adjusted influenza vaccine effectiveness over the last several years, on the best year that we've had, if you look at all comers, it's about 60%. On the worst year, it's anywhere from 0 to 10%. Now, if you look at the last influenza season, I think that is a big wake-up call for all of us. It is the worst seasonal influenza, putting pandemics aside, that we've had since the CDC has been recording hospitalizations and deaths. There were about 80,000 deaths. A typical range is between 12 and 56. There were 183 pediatric deaths and almost 1 million hospitalizations. The vaccine effectiveness overall was 40%, but for the H3N2 that was circulating, it was as low as 25%. So we need to do better there. Next, pandemics do occur, and the response after the fact is generally not effective. You've heard about that from Laurie, you heard about that from Yoshi. Let's take a look now at this. So we were talking during Laurie's presentation about where these viruses come from, and she very eloquently pointed out the situation vis-a-vis humans, birds, and pigs. So the swine flu of 2009, as one of the questions asked, we were looking at China for the first human cases when in fact the outbreak occurred somewhere along the California-Mexican border. The Mexicans said it was from California, the Californians said it was from Mexico, but it was somewhere around there. As it turned out, that was in March of 2009. By April, we already knew it had spread worldwide. Now, under the circumstances of how we make a vaccine, we would have said, we're good to go. It takes about 6 months with egg-based, so let's go May, June, July, August, September, October. Not so bad. Viruses in influenza usually peak in December and January, so we should be in good shape. So Ann Schuckert and I told the Appropriations Committee in April 28th of 2009. We said we hope and believe that we'd have a vaccine ready to go. As it turned out, when the children came back to school in September of 2009, the outbreak had already occurred. And as I always say, there's something very wrong with this slide. The blue line is where the red line should be, and the red line is where the blue line should be. So we had a pandemic, but by the time it peaked, we were just starting to get vaccine to distribute. And when we had a lot of vaccine, the epidemic had essentially almost burned itself out. This is a picture of us trying to explain it to the Congress about how we didn't do it. So when you testify before the Congress, appropriation committees are fun. They give you money. Oversight committees are not so much fun. In fact, you see us, Tom Frieden and I and Jesse Goodman, swearing that we're going to tell the whole truth and nothing but the truth after we were told do you really need a lawyer? In any event, I just say that almost facetiously to tell you that it was really quite disappointing. The other third area is chasing after potential pandemics. What do we mean by chasing after them? You heard about that just a couple of minutes ago from Yoshi. We had the H5N1. What we did is we went ahead and decided, because of the concern that this would be the big flu that kills us all, we developed a vaccine and invested $7.1 billion to essentially improve our ability to respond to these pre-pandemic threats. And the reason I'm telling you this is because we're going to talk in a minute or so about the need for a universal flu vaccine and how that money would have been well spent to try and get us jump-started for a flu vaccine. As it turned out, luckily for us, the H5N1 did not eventuate into a global pandemic. You also heard from Yoshi about the H7N9. The same thing happened. We invested millions and millions of dollars in 2013 to make and stockpile a vaccine, and then we had multiple cycles until 2017. The virus that was circulating in 2017 was still H7N1, but it was not neutralized by the antibodies that were induced by the vaccine that we made in 2013. And this is a story from Stats saying, we concluded the vaccine doesn't provide adequate protection, which triggered yet another round of chasing the pre-pandemic flu. Now, having said that, we have two major challenges. One, the way we produce vaccines, and two, the issue of strain specificity versus universal strain coverage. Take a look at how we produce vaccines. As we all know, the time-honored and effective in many respects of egg-based production of viruses. The problem is you have to make a decision in February or March of the previous year about what you're going to put in your vaccine, and it takes about 6 months or so to get it ready to go. But a number of things can happen in that 6 months. An antigen mismatch, as we know, is a well cause of decreased seasonal flu effectiveness. In 2014-15, we got the right choice in the beginning, but the virus changed when we ultimately got to the season. But what about where the match is a good one? In fact, we had a good match in 2016-17 before we put it in eggs. And as it turned out, the virus, in its attempt to adapt itself to grow well in eggs, mutated. That's the bad news. The worst news is that it mutated in an area which is the epitope for protection on the head of the hemagglutinin. So we had it right in the beginning before we put it in eggs. Cell-based were okay. It didn't have that egg adaptation mutation. So what we really need to do is we need to go, as we're trying, out of egg-based, ultimately, to cell-based, but then ultimately to 21st century platform technology, which is the way we are now pursuing a universal flu vaccine. Be that viral vectors, viral-like particles, nanoparticles, or DNA or RNA vaccines. So this is what we're now referring to as the road or the pathway, hopefully, to a universal flu vaccine. I wrote a paper about that a few months ago, in which I use the terminology I'm using with you today, chasing seasonal flu and why we need a universal flu vaccine. And here's the pathway. We brought together in the summer of 2017 investigators from throughout the country and the world to help us plan a strategic plan and a research agenda, which we've now published in the Journal of Infectious Diseases just a few months ago, where we delineate in detail what the multiple approaches to this are. I don't have time to go through all of it, but the big picture is you need to define first what you mean by a universal flu vaccine, and I think that's what's confusing people. The perfect universal flu vaccine would cover all the flus in Group 1 and Group 2. As you know, probably most of you, there are two major groups of influenza A. The perfect aspirational influenza universal vaccine is likely not going to happen, or if it does, it's going to be in a really long time. So what we want to do, as you can see from the top of that peak of the pyramid down, you're first starting off by strain specificity. Namely, you want to get all the H3N2s. Then you might want to go within the group to also cover an H5, we'll say. And then you maybe want to go to an H1 until ultimately you get a universal flu vaccine. So good news would be if you have a vaccine that covers all the H3N2s and all the H1N1s. That would be really good for seasonal flu, and if you got the right group specificity, it could be good for pandemic flu. We've put together a collaborative influenza vaccine innovation centers to try and get the best and the brightest in the field to try and do that. With the underlying approach for everybody's strategy is to get a vaccine that induces a response to that part of the virus that doesn't change as often as the head of the hemagglutinin. And these are some of the potential targets. I don't have time to go through all of them. I want to focus on one of them that a number of labs are focusing on. And that is the main hemagglutinin protein, which is made up of a head and a stem, as shown schematically here. The critical issue and the stumbling block in seasonal flu vaccines is that the head region, although it is the target of current influenza vaccines and differs from influenza strains, there are many mutations that occur. So if you get it right, you're good to go. But the likelihood is that the next season there will be mutations on that part of the protective epitope, which is the reason why investigators are focusing now to try and induce a response against the stem, which has few mutations. The red dots are areas of common mutations. Now, how do you do that? A number of approaches. Which one will get to the goal line, or which group of them will get to the goal line? We don't know, but there's a lot of work going on. For example, you can remove the head and put in an irrelevant head to focus on the stem, or you could take that stem after you get rid of the head and put it on a nanoparticle, which is highly immunogenic. There have been a number of studies that are going on right now in clinical trial, because I often get asked, you've been talking about a universal flu vaccine for a while, what is the progress? Well, a couple of years ago, if I was speaking to you, it would only be in preclinical work. Right now, we clearly have clinical trials ongoing, and these are just a few of them, some of them as advanced as phase 3 clinical trials. Before I close, I just want to make one comment about another potential, if not real, stumbling block in developing a universal flu vaccine. There's a phenomenon called original antigenic sin, or imprinting. What that really simply means is that your body, your immune system, the first influenza that you see, depending upon what your birth cohort is that influenza that whether you get exposed to a virus or get vaccinated, you will also preferentially revert back and make a good response against what your original imprinting is. That doesn't prevent you from making a response against the current strain, but it distracts the immune response. So, for example, if you were born in an area, in an era where H1N1 was circulating, and that was your first exposure, every time you get exposed to influenza, you will also make a response against to what you were originally exposed to. That is certainly one of the reasons why, and Laurie will relate to that, where you have a pandemic that seems to, for what reason or other, spare younger people, not spare younger people, go for older people, not go for older people. It has something to do with that original imprinting response. So let me close with this last slide by a conclusion that I think we all appreciate. We do need a universal flu vaccine before the next pandemic strikes. We need it for good seasonal coverage, but we also need it to protect ourselves against the inevitable. When that will happen, we don't know, but we do know that pandemics occur, and the best response to that would be a universal flu vaccine. Thank you.